Hello class. Hi Aunt Sylvie.
Hi Louis.
How are you?
I'm great.
Good. So we're going to do a can race today. Very, very important problem in physics where we're racing can down an inclined plane. Right, but we have different shape for our cans. So this one is a hollow cylinder made of metal. What is the other one?
And this one is plain and actually is made of wood.
Yeah, and different mass. Okay. So then they're just going to roll down the inclined plane, and we want to know which one's going to win. So I guess we want to solve for the speed at which they reach about. How would you solve for the speed?
I guess we could use conservation of energy.
That's what I was definitely the easiest. I mean, you could use torque and blah blah blah, but this is a nice before and after kind of problem. We'll just say what is the before, what energy we have at the end.
Well, typically potential, gravitational potential energy.
That's right. They'll start at rest. So they'll just lift it a little bit. So they'll have gravitational potential, and that's going down to
kinetic.
Yeah, and there's no thermal energy loss, static friction. It's rolling, so there's no work done. So it all goes to kinetic.
No, we have two types of kinetic energy.
Oh yeah, so that's the tricky part, I guess. So there's translational and rotational.
Exactly. So the thing is, the translational kinetic energy is our usual mv squared over 2. Now what's the rotational kinetic energy?
That's easy. It's pretty much the same thing, right? Let me write it down. So the kinetical rotation is just 1/2 pi omega squared. Very, very analog to the translational kinetic. And then the inertia, I guess, all of our, it's always of the same form pretty much. It's some number times m times r squared. At least for a shaped disk object like this, right?
Okay.
So which one will win? How do we determine?
Well, we can first look at the two moments of inertia. Moment of inertia, for this one, I think has a factor of 1/2.
So, okay, hello. This one I think that's 1.
Oh, that's the one.
That's all right.
Okay.
And then the other one.
This one has a factor of 1/2.
That's right. And why is this one less?
Actually, it makes sense because here all the mass is repartited on the outside. It's
right.
like a bunch of points on that circle, while here you have masses that's closer to the center.
That's right. So this one is easier to rotate because some of the mass is closer to the axis of rotation.
That makes sense.
Good. So which one will win?
Well,
the hollow or the solid?
Yeah, well, the solid has a lower moment of inertia. So that means that at the bottom it should have a lower rotational kinetic energy, so it should have a higher translational kinetic energy.
And therefore a higher speed.
Yes.
Let's try it.
All right. Well, ready, steady.
And the race starts.
Yay.
Clear winner. All right. But wait a minute. These have different mass. Doesn't that matter?
Oh, that's a good point. Oh, but I think the masses cancel out, right? So you have mgh here.
Right.
And you have mv squared.
And or high omega squared, there's m2. Okay, so the mass doesn't matter. So even though they have very different masses, doesn't matter. We would try like, oh yeah, what about those?
Exactly the same situation, but let's see whether it works again or not. So, yep.
Indeed, yep, this one won. Okay, what about these two?
Oh, so they're both hollow, but they have a different radius.
So they have different mass, but we don't care.
Right.
They're both hollow, but they have different radius. So I guess the one that has the bigger radius should have more inertia.
Should we try?
Yeah.
They actually fall at the same time.
Yeah, it was kind of the same time. Wait a minute, but they have different radius.
Well, the thing is, here you have mr squared, but what do you have here?
Oh, that's right. You got it. So omega is V center of mass divided by R. V over R. And so you're going to square that, and the R's are going to cancel. Omega is going to be V squared over R times the R squared from here, so these will cancel. So that means the R actually won't matter. So that's why these two, they have different mass and different radius, and still they get to the bottom of the same time. Cool. Do you have anything else in your box?
Oh,
Okay, let's try it. What is that one? Is just a solid?
it seems that there's something inside.
Okay.
So 3, 2, 1. Wait, what? Is
Tech-
it broken?
technical problem. Let's call tech support.
So wait, there is a small amount of sand in this one. So how does that affect the motion of the can?
It's too complicated for my head today. Let's leave that to the student. They're really smart.
Okay.